Most people think genetic testing is just one quick test that gives you a yes or no answer. But in real life, it's a whole process. You need to understand, it's about inheritance. They have to decide what tests to run. And then we have to interpret what the results actually mean for a person or their family. In this Unit 2 video podcast, I'm going to explain the genetics side of medical interventions using 4 main sections. The first section, genetic counseling in disorders and categories. The second section is about PCR and how we amplify the DNA. The third section will be about SNP testing with restriction enzymes and gel electrophoresis. In the last section will be how this connects to maternal and child health, plus future of genetics like gene therapy and CRISPR and gene modification. I'm also going to include some quick guess moments where everyday people are asked questions and get to react to these. So it feels like a real world conversation and not just a lecture. So what a genetic counselor does is basically he translates genetics into real life. So they look at a person's symptoms, medical history, and family history, and they determine how they can help and answer questions like, what is the chance of a certain disease running in the family? Or what tests might be needed for that specific family? Or what results actually mean? They also help families deal with emotional trauma, genetic results, and how to make decisions with those results, like pregnancy planning and future health monitoring, or different treatment options. So a big part of what we did in Unit 2 was knowing the different major genetic disorders and their categories. Because the different categories can give you clues about different inheritance patterns, how different traits can correlate into those patterns, and what testing works the best for those categories. So the first category would be single gene disorders. That means that only one gene is altered, and those disorders usually follow a clear inheritance pattern. So an example of an autosomal recessive disorder would be cystic fibrosis or sickle cell. And both parents could be healthy, but the kid could still have that disease because both parents could be carriers of that gene. So the chance of the child still having that is still there. An example of an autosomal dominant disorder would be Huntington's disease or Marfan syndrome. So that often shows up every generation because only one altered copy of that gene is needed for that disorder to appear. An X-linked disorder like muscular dystrophy or red and green color blindness would look more common, especially in males, because since the mother is the only one that can carry that gene, it's passed down through males. If it's single genes, counselors can use pedigrees to predict the risk pretty clearly, and they could choose specific and targeted genetic tests for you or your family. So the second category is chromosomal disorders. So that's where a whole chromosome or a large piece of one is missing, duplicated, or rearranged. And this affects lots of genes at the same time. An example of this would be Down syndrome, where there's an extra chromosome, or Turner syndrome, where there's a sex chromosome missing. Another example would be Cri-du-Chat, which is a deletion of a chromosome. And these often cause multiple body system disorders or defects at once because many genes are involved. And they may happen randomly during egg or sperm formation. Testing often involves looking directly at a chromosome and not just one gene. So the third category is multifactorial disorders, which means multiple genes plus the environment that you're in is affecting you. This category is super common in our current civilization. So example of this would be type 2 diabetes, heart disease, high blood pressure, asthma. And this will look like a cluster of that disorder in the family. But it's not a perfect inheritance pattern because lifestyle and environment raises or lowers the risk of that specific disorder. Counselors usually talk more about the risk reduction and screening because it isn't just a yes or no question. Like, do you have the disorder or don't you? So the fourth category is mitochondrial disorders. This is caused by changes in the mitochondrial DNA. The important inheritance clue is that mitochondria are passed down mainly from the mother. An example of this would be hereditary optic neuropathy or vision loss. So if the mother has the mutation, multiple children can have that disorder, but the severity can vary a lot. Okay, the next section in Unit 2 that I'll be talking about is PCR. PCR stands for polymerase chain reaction. So PCR basically is just a DNA copy machine. It takes a small amount of DNA and makes millions of copies of that same DNA strand, and copies just one specific region so that can be tested by itself. A PCR only needs a few key ingredients. One being the template DNA, which is the DNA you're testing. 2 primers, which is a short DNA sequence that marks the start and the ends of the region that you're copying. The third thing you need is a nucleotide, because a nucleotide are building blocks, and these are used to make new strands. The fourth thing you need is a Taq polymerase, because these are enzymes that build DNA and handles high heat so the enzyme doesn't denaturize. PCR repeats 3 main steps and cycles. 1, denaturization, where heat separates the DNA strands. 2, annealing, where primers attach to the template DNA. And the third step is an extension, where the Taq polymerase would build a new strand. Each cycle usually doubles the DNA because the amount of DNA grows back fastly. So PCR is important because it produces enough DNA to actually run all the other lab tests we have. For my third section of my Unit 2 podcast, I'm going to connect PCR to SNP testing. So SNP is a single nucleotide polymers. That means that there's only one letter being changed in the DNA sequence. But even though it's tiny, that tiny change can be linked to different traits, or it can also change the disease risks. So a way we can detect that is by using restriction enzymes. So these restriction enzymes cut DNA at specific parts or sequences, and if a SNP changes that sequence, the enzyme might cut a little differently or not cut it at all. But if it is cut, after it's cut, we could use a gel electrophoresis, and this separates the DNA fragments by its size. So DNA has a negative charge, and in an electric field, it moves towards the positive end. So smaller fragments would move farther through the gel, while larger fragments will stay closer to the wells of the gel electrophoresis. When we look at the gel, the pattern of the different bands shows us evidence. And these different cuts create fragment sizes. The different fragment sizes creates different band patterns. That's how we infer the genotype. So we can determine if someone is heterozygous or homozygous for a specific allele. This is why PCR plus restriction enzymes plus gel electrophoresis is a usual combination that goes hand in hand with one another. PCR amplifies the DNA. Restriction enzymes cut the pattern in the DNA, and the gel electrophoresis lets us see the results. Okay, on my Unit 2 podcast, I brought a family member who's a knowledgeable person on genetic modification. Let's go meet him. Alright, I'm here with my Uncle David, and I'm going to be discussing what we learned in Unit 2 in my medicals intervention class about genetic testing and what happens after that. So, I'm going to be talking about gene therapy, gene editing, and I'm going to explain it through simple terms and then ask him for his opinion on the subject. So, basically, doctors can test DNA to find genetic problems. So in the future, instead of only treating the symptoms, we're going to be able to use medicine to actually change people's genes. So gene therapy in general is an idea that treating a disease can be done by changing a person's genes with using tools like CRISPR that can edit DNA and cut it in a certain spot. So hearing that, what's your first reaction? Like, what's the first thing you think about, good or bad?
Okay. Well, first, thank you for inviting me on Jordan After Hours. Good to be on this podcast. And a lot of thoughts come to mind when we speak about gene therapy, as they're coining and phrasing it. One of the things that comes to mind is that is several companies that's already been studying and actually running tests with gene therapy over the past several years. And as they get close to actually instituting it, there's some things that I find to be exciting as far as breakthroughs in medical science, but then there's a lot more probably to be worried about than there is to be excited about.
So you already had previous info about this subject?
Yes. I've actually been science, and that's always been something that captures my interest, and medical science really captures my interest because the history of medical science is a wild ride, right? And when we look at hundreds of years ago, how people were treated till currently, it's been a lot of diabolical things have happened to groups of people, and then a lot of breakthroughs have happened through sheer trying to figure out, how does this particular disease or this ailment happens, why does it happen, and I don't want to see anyone go through it. So through empathy, a lot of things also got cured or close to being figured out, right? And when I look at gene therapy, I look at it from a standpoint of what's the overall goal. And to me, I believe that some of the pros to it would be, yes, you can have maybe an ailment like sickle cell that may plague your family for generations. It can then be cured, right? That's great. A lot of people don't have to suffer, and a new generation gets to be born, and it altogether may even wipe out that disease, right? But then when I look at the cons of it, I tend to wonder to myself, if people were able to afford to get this done to either the fetus or preborn child, where they can look at that DNA and modify it or take out whatever they need to take out, well, then you are trying to create the perfect human.
Like a designer.
Exactly, a designer baby, right? And what does that look like in general? So it starts with, we can cure this hereditary disease or something that may that we found in this gene that may activate 20 years from now or 30 years from now. We can get rid of that. But then it also, would you like your baby to have blue eyes? Would you like your baby to have a certain chiseled look? Right? So now people are going to be like, oh man, and with AI technology, you can almost take two people's feature, combine it to see what that child would look like with both DNAs attached, girl or boy, right? And then grow them up to see what they will look like as an adult, and then modify it based on that, right? And as you get further into thinking about this, you start realizing that, where does it stop, right? If you can design the perfect person, who would not utilize that for monetary gain or other nefarious acts? I have a disease that I've been fighting all my life, maybe heart disease or something like that, and now I can create a child out of my DNA and give it a perfect heart that I can then take from that child to keep me alive. Right? And a lot of that would also happen. So it just makes me wonder, what is the overall outcome of this, and how does that affect us as a society?
So we've actually talked about this in class, and one of the problems that came up was militaries making a perfect soldier through this type of gene modification.
And what we can definitely use that as an example. A perfect soldier, right? That's almost saying as if we can create a clone or a human devoid of emotions that don't mind going out to get killed for our benefit. Right?
Yeah.
And the ethical part of it is, from a religious standpoint, a lot of people are saying you're playing God. From a scientific standpoint, is if we can do this, what else can we do? And then also from the way that I look at it is, if you have a generation, maybe 50 to 100 years from now, all created off this premise, now you have a class of people that will say they're the perfect and you are the imperfect. Why should society do anything for the imperfect?
So looking at it through a Marxism type of lens, there's going to be separate classes.
New classes.
Yeah.
Right? The perfect versus the imperfect. And now when you throw politics into it, it becomes, for lack of better words, it's going to be hell. Right?
Yeah,
lots of face.
Yeah, I agree with what you're saying, because if we had that higher class, they're going to look at us as the imperfect type of human, and they might think that we're a waste to this planet.
Yeah.
And they might want to get rid of us.
Yeah, you wasn't born the way we were born, and since our genes are perfect, and not just to look at, you know, the reconstruction of certain DNA, but they're also experimenting with the telomeres that are on our DNA, and the telomeres is what allows us to get older, right? The average human can live to be 120 years old and then die. That's really the cap on the telomere. As you get older, the telomere shrinks. That's in part of the DNA, and it has what looks like two caps on the end of it. Well, they figured out how to modify those caps so that you live longer, possibly up to 500 or more years, right? And this is about to go into a human experiment 2026, because they've already experimented on dogs with it, and they found a dog that had stage 4 cancer. They did the experiment on the telomeres, and the dog reversed in age. The cancer went completely away, and the dog's fur, which was getting old and gray, reverted back to the fur as if it was a puppy.
So you're saying there's already been successful trials?
It's been successful, completely successful, over a group of 12 or more dogs. And human trials start in 2026. So now you take gene therapy and you add it with that. Not only do you have a perfect human that was designed how you needed them to be designed, without disease and any other ailment implication, but now you gave them longevity of life, right? So add that to this new ruling class versus those that can't even afford it, right? So again, you have a girl that you're seeing, you two are growing within your relationship, decide that you want to get married and have a child, and you and your lady have a discussion about, you know, family ailments, right? I have sickle cell or lupus in my family, and my girl, they have Down syndrome and a few other things like that. And there's what's the implications of us having a child and that not being passed to our child, one or the other or all, right? Well, to get the cell therapy or gene therapy, $250,000 or more, and it's not covered by insurance because it's cosmetic.
Yeah, something the average person can't afford.
So now you have only the politicians and basically rich people or athletes that can afford it. Well, what are athletes going to do? They're going to have children and make even more perfect athletic children, right?
Yeah.
Politicians are going to make more perfect, polished individuals that can run society, and not only run society, they have years now, hundreds of years, right? And it just gets crazier and crazier. And then let's say none of that occurs. But what does occur is what scientists are doing and medical science is doing is curing children that may be born with pre-illnesses. But what does that say about those that already exist with the illness? How does that help them? Right? And so does medical stop at those that are being created sort of perfectly and no longer look at those that currently still exist with conditions and no longer care to fight those ailments? So so I think is more cons to it, and none of us were made to truly be perfect, or we would have been already created that way.
Okay, if this gene therapy was affordable to everybody, in a genetic disorder standpoint, do you think that this would be a good thing and that would outweigh the downsides?
Not necessarily, because what does that do to a person's personality that was born with everything, and everything meaning looks and kind of a perfect organism, body health and all? How does that shape the way that that person thinks as they get older, right? Knowing that you're not going to get sick, you're not the average individual, does that play with your mind to make you think that you are better than everyone else that you come across, right? So I'm not sure how it will help on a psychological level. So I still think that there are implications there, that it could be good for if it was affordable to everyone. But then how do we treat those children that are born like that so that they don't become so that they don't become butt munchers? I don't want to butt munch for a child that thinks they're better than me or you or all these other people.
It's going to impede future generations' thinking.
Yeah, it definitely will. Because you got to think, if you can modify that, then most likely you can modify how that child learns. You can modify how they pick up information, right? Along with other things. And you could have some of the most smartest children ever in society, gifted in that way. But still, what does that do to a society that is imperfect when the perfect start realizing that they are perfect from the concept of what we conceive as perfect to be? For the time being, I think that rather than looking at gene therapy as something for helping new lives that are created, they really should concentrate on how can gene therapy help those that exist with modern day problems. So if I was to, a person that has diabetes, type 1, right? How could gene therapy help cure their pancreas or their kidneys or anything like that? They'll get it back into working everyday condition. And then would the pharmaceutical companies even allow it? Because that takes money out of their mouth and they're all about profit. So what does that do to those companies that are profit based, that's not trying to see their margins go into go or dip into very low places that could bankrupt them, right? What does that do? So I'm not really seeing, one, if it will become something that's viable in today's society that's based off of greed and can you do for me? I don't see how it will become viable in today's society. But I think it will be good if they started with those that are already sick, or you know,
So just focusing on gene disorders?
yeah.
Okay,
Gene
what
dis-
about multifactorial disorders like stuff like asthma or type 2 diabetes?
Again, if they're focusing on those that exist with it, and when I say those that exist with it, I can understand if they don't want to look at people 50 or older, but children to young adults, 30, 40, those that still have a lot to give to society. And not saying people 50 or older can't give to society, because I'm 50, right? So that's like saying I don't want to be cured or anything, right? So I'm not going to look at it like that, right? What I am saying is to those that can use it and gain more from it, the sick of the sick, right? And even if we talk cancer, right, stage 2, 3, 4, if something could be modified to fight off that, I'm all for it. But let's start with those people that currently exist with conditions, rather than everything that I've studied. They're really looking at newborns and fetuses and things of that nature. And I understand why, because that's the perfect testing ground. You can get statistics and data off of that for years to come. It's hard really to get statistics and data off of someone that maybe 30 to 20, that's not going, 30 to 40 or 40 to 50, it's not going to tell you as much as monitoring somebody from birth all the way to their 25. That gives you way more data, way more history, and you get to watch the development of the mind and how they get acclimated to society. So yeah.
Okay, we could probably keep talking for hours, but I gotta finish this podcast at some point. So I want to thank you for coming on my podcast as a genetic modification expert.
I appreciate it. Thank you. I'm not that much of an expert, but I do like having good conversations, and you provided me with that. Thank you.
Mm-hmm. Okay, for my fourth section in my Unit 2 podcast, I'll be connecting Unit 2 genetics to maternal and child health. One big concept is the difference between screening tests and diagnostic tests in pregnancy. Screening tests estimates the risk. They can tell you something like if there's a higher or lower chance, but they can't confirm the actual condition. Diagnostic tests are meant to confirm. These can include procedures like CVS, which can provide more direct genetic information. The reason this matters is because screening tests are often used first, since it's less costly, and then the diagnostic testing is used if the risks appear higher or more certainty is needed. This is where genetics becomes very real, because the information can influence medical decisions and family planning. Finally, Unit 2 also looks forward. Testing is about identifying a problem. A modern medical intervention is also great, and is also pause it. Finally, Unit 2 also looks forward. Testing is about identifying a problem, but modern medical interventions are also about what we can do after identifying it. A major topic is gene therapy, and there are 3 simple ways to think about it. The first way is insertion, and that's working with a copy of the gene. The second is disabling a harmful gene, and the third is repairing a gene and its functions. This connects to what we said about CRISPR, which is a gene editing tool that can target specific DNA sequences The potential benefit is treating genetic diseases closer to the source instead of only treating the symptoms. But there are also ethical questions. Where do we draw the line between treating disease and enhancing traits? Who should we have the access to choose between this? And how should we protect the privacy when genetic info can affect entire families? So Unit 2 isn't just lab techniques. It's also about genetic and how they affect choices of people and their futures involving medicine. To wrap it up, Unit 2 genetics is a chain of reasoning and evidence. Genetic counseling helps interpret inheritance and risks. PCR amplifies DNA so we can test it. Restriction enzymes and gels help us interpret genetic differences through band patterns. Maternal and child health shows how these results guide real decisions. And gene therapy and CRISPR shows where genetics might go next in modern medicine and how we should approach it ethically. Since I'm grounding this to real medical information, I'm using sources from the CDC and the NIH Medline Plus, and I wrote them on the board behind me.